So this video will be the first of a series in which we try to tackle one of the more difficult objectives for Chapter 7, which is to factor a trinomial in the form ax squared plus bx plus c. And if you look at that as a trinomial, we've seen that before. You've got some nice symmetry. You've got x squared on your first term and a number at the end, a constant. But this new feature of the a in front is what makes this challenging. So we're going to start taking a look at it by the strategy of guess and check. Not something we really rely on a whole lot. It's not the most efficient thing in the world, but it really does connect nicely to what you understand. So it's a good place to start. So here's the only experience we have so far. If I give you this trinomial, you might recognize it as the last problem from our previous homework. And the scenario there was, at first I gave this to you as a 4-term expression, and I was having you factor by grouping. But we kind of made this hypothetical where someone noticed, well, these 4 terms that I handed you could be rewritten as these 3 terms. And I hope you came to the conclusion that if those 4 terms factor a certain way, then these 3 equivalent terms would also factor the same way. And what I asked you was to try to start convincing yourself that this expression factors that way. And I hope you did some things like this, like you noticed maybe the 7q and 2q are exactly what you would hope to see, or at least one of a few that you would hope to see if you're going to try to create this first term 14q squared. Similarly, the 2 and the 3, if you think about trying to multiply from this binomial times binomial up to here, you would expect to see some numbers that multiply to 6 here and here, maybe 2 and 3, maybe 1 and 6. Let's talk a little bit about the negatives. The negatives, we could have figured that out because while 2 and 3 multiply to 6, and they multiply to positive 6. When we think about the other possibilities, -2 and -3 is also a factor pair of positive 6. And in this case, it ended up being the correct factor pair. And that only comes out after you think about the check. So there's your first term, which is really in good shape when we look at the 14q squared and look at the 7q and the 2q. The -2 and the -3, they look nice because if you multiply those out, you get a positive 6. Your last term is kind of clear. And that middle term, that -25q, that's always the tough one because that is a combination of your outer and your inner together. But back to my comment about the negatives, if this was a negative term in the middle, and you were trying to figure out if this should be a +2 and a +3 or a -2 and a -3, if you're trying to combine your outer and inner products to make a negative, I think you better get your negatives somewhere. So when we look at this positive sign, we start to think, well, that means that the symbols that I fill in here are going to match each other. They might match as positive, they might match as negatives. But when you bounce it off of this middle term and think, well, hold on, that's a negative in the middle, that tells me these are both going to be negative. So we'll keep an eye out for that as we go. So the strategy of guess and check, it's you don't blindly guess. Like you know that you need to get the 7 and the 2, or maybe a 14 and a 1 to satisfy the 14q squared. But you have to, whatever you guess, your smart guesses about how you split up the 14 and split up the 6, you are going to have to check the outer and the inner. And you're going to see that throughout. So let's look at a different problem. A lot of similar things here, that 14q squared, that positive 6. So I would think that this over here is actually not a bad guess for factoring this thing, because you still have the 14q squared and the positive 6. But if we were to check it, which we already did down here, we could see that we don't have the correct outer product and inner product to match our 19q. It was great at matching the -25q, but not so good at 19. So let's look at this a little bit further. We don't need to guess that it's going to be a binomial times a binomial. We've seen enough of these things now where there's that kind of symmetry and there's a q squared and a constant. I don't think we're guessing at 2 sets of parentheses, each big enough for 2 terms. I also don't think we're guessing when we say that we're going to put a q on each, because if we do that kind of symmetry, we're going to have the means of making a q squared and a q term and another q term, and we'll also have, by putting no variables here, we have a way to make the 6. So I don't think we're guessing there either. Now, with the positive 6 at the end, as I already touched on, if we think that they need to match, we could guess that it's a positive, but I think it'd be a smarter guess that they're both negative. That's because, again, this negative right here. So I don't think we've guessed much yet at all. We've done some pretty good deducing, really. The guessing starts to come in when you think of how you break up the 14, because the 14 could be, and how we break up the 6, because the 14 could be a 1 and a 14 like it was in the last problem, but we have to be open to the possibility that it's a 2 and a 7. And with a 6, you've got a couple possibilities too, a 1 and a 6 or a 2 and a 3. So we have to guess at how we're going to split up the 14 and the 6. And then we have to check, like I indicated down here, we have to check the outers and the inners that are created and see if we can't match up the negative 19. So let's start with one of these guesses. I'm gonna use this version of 14. And I'm gonna put a 1q here, and I hope you're thinking right away, if you put a 1q here, then that kind of comes in concert with the 14q here. That takes care of this. Now we have to pick one of these guys, and it just you have to be systematic, however it is. So the first ones came to mind are a 1 and a 6. So that's a decent guess. As far as I'm concerned, any good guess is going to be one where the factors of 14 are here and here, and the factors of 6 are here and here. The check, though, is going to come about by, again, doing my outer and my inner, and seeing if a outer product plus an inner product get me to a negative 19. And that was pretty close. Negative 20q is what we would have gotten there. But close isn't good enough here. It wouldn't have been equivalent, so that's out. The negative 19q is going to be what we're going to check against. So let's do another guess. Let's not mess with the q's. Let's keep those as they are. And let's not mess with the version of 6 that we're going with either. But let's just rearrange them, because we do get a different outer product and a different inner product if we simply just change the 1 in the 6th place. But still, it's a good guess, because we've got our 14q squared. We've got our positive 6 here. The only check we have to do is our outer product and our inner product. So my outer product is a negative 1q. My inner product is a negative 84q. I don't think that that's matching my negative 19. So that's it. Now, what do we want to do for our next guess? You've got choices. So your system is going to be your system, but I'm going to keep going with the 1 and 14. And I'm going to start to use this version. So I'll put a 2 here. I mean, it's as good a guess as any. And you should now know that if I'm putting a negative 2 here, what number goes here? Well, we're still trying to consistently make sure we've broken up a positive 6. So we should put a negative 3 there. And we'll check our outer and our inner again. 3 and 28 this time. That's a 31. 31 is not a 19. That's out. Next, let's go with our 1 and our 14. And this time we'll rearrange the 2 and the 3. And you might be getting tired of guessing. And this is actually, we're pretty lucky here, because there's very few factors of these guys, but you might be getting tired. So at this point, I want to introduce something else. It's a little bit of an advanced move, and especially for your first example, but I want to point something out here. This factor here is going to start getting your attention once you've got some experience here, because the 14q minus 2, if we notice that one, there's a common factor in there. Like, this factor makes it, if this is going to work, it means that we could have a 2 as a part of a more prime factorization of this thing. But when you look back at the original expression, there is no common factor 2 all the way across. So what you can start doing is you can start eliminating guesses before you ever write them down. If it has a common factor in one of your factors that you're trying, but the expression that you're factoring doesn't have a common factor, then it's not a good guess. So I feel like we've exhausted all the 14s, 1s and 14s. Let's start moving on to the 2s and 7s. And at this point, again, your system's your system. We could fill in these blanks with, hopefully, numbers that are going to multiply to 6. And if we're using the 1 and the 6 first, I also hope it dawns on you that this is not a great place for a 6. We had just finished saying that if we create a factor that has a common factor in it, but your expression doesn't have a common factor, then it's not really a good guess. So I'm not going to put my 6 here. Let's instead put my 1 there and my 6 there. And now I see no common factors. It's worth checking. My outer product is a negative 12. My inner product is a negative 7. And actually, we got it. Negative 12 and negative 7 is negative 19. So that is the outer product and the inner product we were looking for. So our factored expression then would be what we have down here, 2q minus 1 and 7q minus 6. I told you it's a challenging thing. We're going to spend time right now just trying to identify good guesses and bad guesses. And then we'll give you some problems where you have very few guesses that you can make. And we'll do that for a day or two. And then we'll move on to some other ideas that you might find a little bit more convenient. So be patient with this one. It takes some time.